I am Dr. Nicholas Sammut, and today I'm going to give you an introduction to the Large Hadron Collider, also known as the LHC. We also know it as the Lord of the Rings. First of all, before we go into what the Large Hadron Collider is, we'd better give some background on the organization that houses the Large Hadron Collider. The organization that houses the Large Hadron Collider is called CERN, or also known as Conseil Européen pour la Recherche Nucléaire. It is an international organization and is the largest particle physics laboratory in the world. It is highly non-military, and it is also composed of fundamental research, the composition of matter, and the mechanisms of forces at the subatomic scale. CERN was founded in 1954, preceding the European Union, and hence it is a shining example of international collaboration. It has about 6,500 specialists in engineering, computing and physical sciences, and has about 600 million euros per year in budget. If you look at CERN from above, you will see a number of villages, but superimposed on those villages, if we were to bring up the Large Hadron Collider to the surface, because at the moment it is 100 meters underground, you would see that it spans 5 towns and is covering a very, very large area. In fact, the largest ring, the Large Hadron Collider, is 27 kilometers long. As you can see from this picture, on the right you have the Geneva Airport and the Geneva Lake, and on the left, the dark patch, those are the Jura Mountains, mountains that predate back to the Jurassic era. So they are very, very old, and this is the terrain that was used for the Large Hadron Collider because there is a lot of geological stability. CERN is made up of 21 member states, the latest of which is Israel, and they are shown over here in this map, and these are the states that primarily fund the organization. This slide is also showing the whole accelerator infrastructure, or known as the accelerator chain. So first we start with the LINACs, and then we go into the proton synchrotron booster, the proton synchrotron, the SPS, the super proton synchrotron, and then the LHC. Then there are a number of other lines, like for example LAIR, which is the low energy ion ring, and the CNGS beam, which is CERN Neutrinos to Gran Sasso. These are separate experiments that come as add-ons to the Large Hadron Collider. In the next slide we have the a schematic of the Large Hadron Collider, and you can see immediately that it has 8-fold symmetry, with 4 different accelerators. So in IP5, for example, we've got CMS, the compact muon solenoid. In IP1 we've got ATLAS. In IP8 we've got LHCb, and in IP2 we have ALICE. These are the 4 intersection points where we have detectors. So basically the beams collide together, crash, and out of all the small bits and pieces that come out of it, we try and understand what the fundamental nature of matter is at the most fundamental layer of our current knowledge. As we said, the Large Hadron Collider is in fact 27 kilometers in circumference and is 100 meters underground. This is for it to be shielded from all radiation, and for radiation to be shielded from actually going out to the surface. The cost of the machine is about 6 billion euros as of the startup summer in 2008. And the primary goal of the Large Hadron Collider is to look for the Higgs boson, supersymmetry, CP violation, the quark gluon plasma, and extra dimensions. Over here on the right we also have what is called the Standard Model, and the Standard Model is actually kind of a periodic table that we've got in chemistry, but at a much more fundamental level, at the particle level. And the goal of the LHC is actually to try and fit this Standard Model together. Unfortunately, the standard model just doesn't fit. It doesn't seem to gel well. There seem to be some missing pieces. There seems to be some missing concepts that we cannot understand, and hopefully the Large Hadron Collider will shed some light on this. The LHC, in fact, acts like a giant microscope. It probes down into the subatomic range for us to try and see what there is in this very, very small range. In fact, what the LHC really does, it kind of bashes particles against each other, collides them, and from the bits and pieces that come out, we try and figure out what these collisions were made of and what matter was built at this fundamental stage.